little bit of a walkthrough of some of the questions in your Pure Maths 1 exam. The first one is a trigonometry question, and we've got 3 sine squared 2 theta plus 8 cosine 2 theta equals 0, and we're trying to solve and find the solutions to this between 0 is less than or equal to theta and is less than or equal to 180. Now, straight from the outset, since we're working in 2 theta here, that must mean that 2 theta is between 0 degrees and 360, since to get from here to here we must divide by 2. Now, when you're dealing with trigonometry, you want to be probably in generally in either sine or cosine or tan when you're solving an equation, generally. And you know a rule for converting sine squared thetas. So this is the same as 1 minus cosine squared 2 theta plus 8 cosine 2 theta equals 0. So we have minus 3 cosine squared theta plus 8 cosine 2 theta plus 3 equals 3 times minus 3 is minus 9 cosine theta, plus 1 is minus 8 cosine theta. Oh, I should be in 2 thetas here, shouldn't I? Just fix that up. That's 2 theta there, and that's 2 theta there. Okay, so now we're ready to solve this. We've got cosine 2 theta equals, here it must be equal to minus 1/3, since the whole bracket must be equal to 0 to cause this to be true. So minus 1/3. And here, cosine 2 theta must be equal to 3. But you know that that's undefined. Cosine theta is only defined between minus 1 and 1. So this, we're going to have no solutions for this. Now let's look at this example here with our cosine graph. Cosine graph looks like this, between 0 and 360. Now we're in degrees, so make sure you're set to degrees. Inverse cosine -1/3. So just get rid of that. 2 theta is equal to this. And I'm getting 109. So remember, this is 180 here, so 109 somewhere over here. And there must be another result in the range, which is this one here. And we know that this one, using symmetry, is going to be 109 from 360. So you go, so I've got 2 theta equals 109.5. And then I'm going to go to find my other one, 360, take away that. And that will give me this one here. So this is 250.5. Last step is to find theta, because that's 2 theta, and I divide both of these answers by 2, so I've got 125.3, 54.75. Okay, so the second part of the question is asking us to figure out the values of A and B, and we're given these values here. Obviously this one is negative pi over 6, 0, and this one is 0, pi over 3. So these are values on this curve. Now obviously, because we've got these kinds of values here, we're going to be dealing with radians. So radians. Okay, so well, we can do a sort of a simultaneous equation, can't we, really? We could say, well, at this point here, our y value is 0, so 0 is equal to A plus, and then chuck in what tan B minus B pi over 6. And the second thing we know is that square root 3 is equal to A plus tan minus B times 0. Okay, so this is nice and easy, isn't it, really? Because that's simply, so this is equation 1, this one here is simply going to be square root 3 is equal to a plus, and we know tan 0 is 0, 0. So a is equal to square root 3. Now at this point we can chuck this into here, into our first equation. So 0 equals square root 3 plus tan minus b pi over 6. Alright, and I'm going to pop this over to here, so I've got negative square root 3 is equal to tan minus b pi over 6. And then I'm going to take the inverse, so the inverse tan of negative square root 3 is equal to minus b pi over 6. Negative pi over 3, that's this value here, is equal to negative b pi over 6. And I'm going to times both sides by minus 1, so that will get rid of these. And then I'm going to times this side by 6, both sides by 6, so 6 pi over 3 is equal to b pi. So 2 pi equals b pi, so therefore b is equal to 2. And we're being asked in quadratics, and we're being asked to express this in this form. So this of course is completing the square. So first step, x half this minus 2, square it, and then subtract off this minus 4, plus our 7 that we've already got. So this bit here is that bit there, and then the 7 is that bit there. So and so final answer for this one will be plus 3. So we've put it in that format. Okay, and we know that this function is, so part 2 now, this function is defined for x is less than k, where k is a constant. So we've got to write down the largest value for k, for which f is a decreasing function. Well, let's just sketch this, right? Okay, so it's going to be this kind of quadratic, because it's a positive quadratic, and that makes this valley shape. And we know that this point here, the minimum point, is going to be at 2, 3, right? I think we've talked about this before. If you're not sure how I get that, you can have a chat to me, email me, and I'll explain it. But I'm pretty sure we've done that before, so you should be right with that, I think. Okay, now for where it's a decreasing function, in other words, where does it have a negative gradient? Well, okay, all the way along here, then it becomes a 0 gradient, then it becomes an increasing function. So k must be this x value here, so k is equal to 2. That would be how I would go about solving this one. So just a one pointer there. Okay, then now for the third part, part 3, we are told that k is equal to 1. Okay, so it's over here somewhere. And we need to find an expression for the inverse, and we need to state its domain. Okay, so we'll go y is equal to x squared minus, no, we will use the work that we did in part 1, of course. We'll use this, x minus 2 all squared plus 3. Then we do our magic wand, swap our x and y's, because that's what an inverse is doing. Okay, pop the 3 across here, so it'll be x minus 3 is equal to y minus 2 all squared. Take the square root of both sides, so this will be plus or minus the square root of x minus 3 is equal to y minus 2. Just going to move up here because we're running out of room. Y must therefore be equal to 2 plus or minus the square root of x minus 3. Now you've got to decide which one it is, because we talked about those functions needing to be one-to-one and having to eliminate one of these. Well, obviously, since we're on this side of the curve, it's going to be the minus one. So our answer will be minus. So we're going to say, what are we dealing with here? F, yep. So the inverse function will be 2 minus square root x minus 3. The last part of this question is asking us for the domain of this. Now the domain of your inverse is equal to the range of your original function. Now the range of our original function, if k is 1, is that upwards. So all we need to do is chuck in a 1 to our original equation. 1 minus 2 is negative 1. Negative 1 squared is 1. 1 plus 3 is 4. So our original range was function is greater than or equal to 4. Here we're going to say that our range, our domain must be x is greater than or equal to 4. Okay, here's our final one. We have gx is equal to 2 over x minus 1 for x is greater than 1. And remember our fx function was equal to x minus 2 squared plus 3. Okay. So in this last question from the practice ones, what you have to do is you have to find an expression for g(f(x), this composite function, and we're going to state the range for it. So first of all, we're going to start with putting this into this. So it'll be g, and in g we're going to put x minus 2 all squared plus 3. That is going to become the x value here. So it will be 2 over x minus 2 all squared plus 3 minus 1. And we can say, well, this is equal to 2 all over x minus 2 all squared plus 2. So the last part of the question is to find the range of this composite function here. Well, I've just written up a few points here. We know that that for this function x is less than 1. So when we plug in less than 1, or when we plug in 1 we get 4. 1 minus 2 is minus 1. Minus 1 squared is 1. Plus 3 is 4. And then we plug that into the gx to get our composite function, and we get 2 over 4 minus 1, which is 2 over 3, which is 2/3. And then what you want to do to find out the range is you want to see what's happening with this function as we plug in other numbers into it. So let's say what happens when we chuck in f0. 0 minus 2 is minus 2. Minus 2 squared is 4. 4 plus 3 is 7. And so we chuck in 7 here. 2 over 7 minus 1 is 2 over 6, which is 1/3. Alright, let's see, we're going down. Let's see if this trend continues. Let's chuck in minus 1. Minus 1 minus 2 is minus 3. Minus 3 squared is 9. 9 plus 3 is 12. We chuck that in here. 2 over 12 minus 1. That's 2/11. That's smaller than 1/3. We'll try one more and hopefully you'll see a trend. Let's go minus 4. Minus 4 minus 2 is minus 6. Minus 6 squared is positive 36. Plus 3 is 39. 39 minus 1 at the bottom there. So it'll be 2 over 39 minus 1, which is 2 over 38, which is equal to 1/19. You can see that the values are getting smaller and smaller as this x value becomes larger and larger. So as we input numbers smaller and smaller into this function, the denominator becomes smaller and smaller. It's going to get closer and closer to 0 but never touch it. So our range is going to be 0 is less than g(f) of x is less than or equal to is less than 2/3. And that will be the answer for that one.